So this is just a quick tutorial on recursively defined sequences. So what's a sequence? A sequence is a list of numbers in a particular order. So here's a sequence: 4, 6, 8, 10, and so on. In this sequence, 4 is the first term, 6 is the second term, 8 is the third term, 10 is the fourth term, and so on. So 4 is the first, 6 is the second, 8 is the third, 10 is the fourth. The fifth would be the next one. The ... means keep going, keep doing this out forever, following the same pattern. When we are describing a sequence, there are several ways that we can do it. One way is to talk about how we go from each term to the next term. So in this sequence, it's pretty easy to see that as you go from 4 to 6, you have to add 2. And you do the same thing when you go from 6 to 8. And when you go from 8 to 10, you also add 2. To go from 10 to the next one, what do you think we're going to do? Well, we're going to add 2, just like we've done the rest of the time. Because we're adding 2 each time, and that means that each number is 2 away from the number before it. 2 is called the common difference here. Now, we can write this by talking about each term. We're going to use the letter U to talk about the terms. And when I put a little 1 down here, that's a U sub 1 is how we say it. That's a little subscript. It doesn't mean anything mathematically. It's not like an exponent. It just means the first U. And the U's are going to be these numbers. So what's the first U? Well, the first U is 4. What's the second U? U sub 2 is 6. U sub 3 is the third U. That's 8. U sub 4 is the fourth one. That's 10. Now, why would I write this? This seems like I'm just writing the same thing as the sequence, but with more stuff. We don't like doing more stuff. That's kind of a pain. Well, I write it this way because maybe I want to talk about the nth U. So I want to talk about a U here, but I don't want to specify which one. I'm just going to say it's the nth one. Now, this is kind of nice because, well, how did we get 6? We did 4 plus 2 to get 6. And how did I get 8? I did 6, the one before it, plus 2 to get 8. And to get 10, I did 8 plus 2 to get 10. So here, the n down here is standing in place of which term this is. So how did we get each term after that? We did the term before it. Well, how do I write the term before the nth term? Well, what number comes before n? N's not a number, I hear you say. You're right, but it's standing in place of a number. So how do I find the number before it? If n is 4, how do I get 3? If n is 3, how do I get 2? Well, we take away 1 from n. So U sub n minus 1. This means the term before. This means the previous term. And what did I do to the previous term to get the next term? Well, here we added 2. So this can sort of describe my whole sequence, right? To get each term, you take the previous one and you add 2. So that's kind of handy. That's a handy little notation. I don't need to write all of these things. But what about if all I had was this rule? Would I be able to get this whole sequence? Well, let's say n was 1. Then that would mean you take the 1, take away 1, the 0th term, but there is no 0th term, or at least I don't know what it is. So we find that this rule will work to tell me how to find all of the terms after the first one. Once I know the first one, I can use this rule. So I have to have this rule along with this one. So these guys together can make up our recursive definition. Now we do have to, just to be kind of picky here, we do have to specify when this rule can be used. This rule is used when n is greater than or equal to 2. So if n is 1, we're just going to use this rule. Piece of cake. Oh, it's 4. If n is greater than or equal to 2, we use this rule. So if n is 2, what does that mean? Well, if n is 2, 2 take away 1 is 1. So this thing in the yellow box is u sub 1. Do I know u sub 1? I do. It's 4. So I put 4 plus 2, and that tells me that u sub 2 is 6. So let's see how this works. Let's try to use a couple of rules to write a sequence. Let's say u sub 1 is 10, and u sub n is equal to u sub n minus 1 plus 6. And we're going to use this rule when n is greater than or equal to 2. We're going to have this part happen so often that eventually we're just not going to write it. And we'll know that if you're looking at this, if it tells you what one is that you're looking for, then use it. Otherwise, you have to use this one. So let's see if we can figure out what this means. U sub 1 is 10. So I'm going to write down my terms. So what's the first term? Well, the first term is 10. How do I know it? Because it tells me right there. So that's 10. Yay, that comes from right here. Now the second term, it doesn't tell me a second term. N is 2, so I have to use this rule. You know what, I'm going to draw a line right here to help me separate those things visually. So this rule, what the heck does this mean? U sub n is equal to u sub n minus 1. I'm going to draw a box around that because that's like one big thing, plus 6. So if n is 2, u sub 2 is equal to u sub 2 take away 1. 2 take away 1 is 1 plus 6. So u sub 1, what does this mean again? The previous term. So to find the nth term, we take the previous term and we add 6. So to go from this to this term, we add 6. 10 plus 6 is 16. To find the third term, I don't have a thing, I got to use this rule. We have to use the previous term plus 6. That's 22. To find the next term, we got to add 6. 28. To find the term after that, well, what do we do? Oh, gee, I don't know. Oh, yeah, add 6. 28 plus 6 is 34, and so on. We call this a recursively defined sequence because recursive means to run again. And what we're doing is we're running this rule again and again and again with new numbers to get each term after that. This is a really natural way for thinking about sequences of numbers, and it, in some cases, can be the best way of thinking about things. We're going to see later on other ways of talking about sequences of numbers, but for now, let's talk about recursively defined sequences. Let's see if you can do one. U sub 1 is 18, and U sub n is U sub n minus 1 plus 5 when n is greater than or equal to 2. See if you can write down the first, second, third, fourth, and fifth term. All right, good luck. So here's the answer. I'm going to draw my line to help me not get confused. The first term should be the easiest. Well, what's the first term? Well, this tells me that the first term is 18. Now, to find each term after that, I have to follow my rule. My rule says to find the nth term, I take the term before it, previous term, and add 5. So to get the second term, we take 18 and we add 5. To find the third term, we take 23 and we add 5. That'll give me 28. To find the fourth term, we take 28 and what do we add 5. That's 33. To find the fifth term, we add 5 again. We get 38. Is that what you got? If you did, good work. Now, there are a few different types of recursively defined sequences that we want to talk about in particular. And it has to do with whether or not to go from one number to the next we're adding something every time, the same thing every time, or if we're multiplying by something each time. And this comes from a couple of ideas. If we have a couple of numbers and we want to compare them, like suppose we want to compare the numbers 2 and 10. Well, how can you go from 2 to 10? There's a couple of ways. We could add 8. That's called the difference. Let's talk about how I find the difference. You probably can just look at that and say, oh, we need to add 8. But suppose these numbers were trickier or bigger. I want to figure out a way of finding the difference. Well, the difference is we take the second number and we subtract the first number. That tells me how much I have to go from the first number to get to the second number. When you're finding differences, it always feels a little backwards because you're doing the last number minus the number before it. But that's the case here because we're trying to find what we need in order to move forward. So we have to do it backwards. Well, adding 8, that's one way of going from 2 to 10. But is there any other way? Well, sure, there's lots of other ways. The next sort of easiest is to multiply by 5. 2 times 5 is 10. This number is called the ratio. Now you can probably look at 2 and 10 and say, oh, I know I need to multiply by 5. But most of the time you're not going to be able to just look and know. So how did I find that? Well, it's a lot like we did to find the difference. We take our second number, 10, and we divide it by the first number. I was going to write an old school 5th grade division symbol there, but we're too cool for that. 10 divided by 2 is 5. And that's called the ratio. And again, notice we're going kind of backwards. 10 divided by 2. And that's because we're trying to figure out what we need in order to go forward, so we have to move backwards to figure that out. These two things, these two different ways of going from one number to the next, will give me two very different sequences. If we are adding 8 here, the next number would be 18, and then 26, and then 34. If we're multiplying by 5, the next number is going to be 50, and then 250, and then 1,250. So you see that depending on which way we go, whether we're using a difference or a ratio, we get two very different sequences. So let's talk about what those two sequences are like. I'm going to write this on the back of this page here. So these are two types of sequences. They're not the only two types of sequences, but they're the only two types that we're going to care about right now. So the first type is called an arithmetic sequence. It looks like it says arithmetic, but we call it arithmetic. Now, an arithmetic sequence uses a common difference. This is where we're adding the same thing every time, or even subtracting the same thing, because if you want to think about subtracting as adding a negative, it's the same thing. So arithmetic sequences have a common difference. Their rules, recursive rules, will look like this. U sub 1 is going to equal some number. And the recursive rule looks like this. U sub n is equal to u sub n minus 1, the previous term, plus some number that's a common difference. This number is called the common difference. You've seen these types of sequences before. You may not have known it, but you have. So the way this works is you'll start off at some number, and then every time you go to the next term, you're going to go up the same amount, 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 up the same amount. If you were to draw a line through those dots, or a curve through those dots, you would have a line. What did we call equations that gave us a line in Algebra 1? Oh yeah, those were called linear. Arithmetic sequences give us numbers that are linear. They all go in a line. That's the first type of sequence. That's the type that we looked at on the other side of this page, where we're adding the same amount every time. The other type is called geometric sequence. Now, geometric sequence doesn't mean that this is going to involve shapes and squares and things. I sort of think of it as sort of a level up from arithmetic. Arithmetic is easier than geometry. Arithmetic sequences are sort of simpler than geometric sequences. Geometric sequences have a common ratio. So this is where we're going to be multiplying by something each time. The recursive formulas for these look like this. U sub 1 is going to equal a number, same as before. And U sub n is going to equal U sub n minus 1 times some common ratio. So this number is a common ratio. Oh, but you know what? That was really silly of me. That's not how we're going to write this. We're going to write this like this. U sub n is equal to the common ratio times U sub n minus 1. Because The common ratio is going to be some number when we write these, and we usually put numbers first before variables or things like u sub n minus 1, which is the previous term. Now you've seen these before also. These guys are ones that as you go each step, you are adding on an increasingly large number. And if you drew the line through these guys, you would get a curve that is exponential. You talked about exponential functions in Algebra 1. Geometric sequences give us numbers that are exponential. Well, let's take a look at a geometric sequence, because they're fun. Okay, so here's a sequence. U sub 1 is equal to, let's say, 5. And U sub n is 2 times U sub n minus 1. We use this rule when n is greater than or equal to 2. I'm going to draw the line. So let's find some terms here. So the first term. What's the first term? It's 5. How do I know that? Because it says so right here. The first term is 5. The second term, well, how do I get that? Let's look at my rule. My rule says to find each term, to find the nth term, we do 2 times u sub n minus 1. 2 times the previous term. So to go from 5, the first term, to the second term, we're going to multiply by 2. 5 times 2 is 10. To go from the second term to the third term, we multiply the previous term by 2. So we multiply by 2. 10 times 2 is 20. To go from the third term to the fourth term, we're going to multiply by 2. 20 times 2 is 40. To go from the fourth term to the fifth term, we're going to multiply by 2. The fifth term would be 80. Geometric sequences have numbers that grow quickly, or can grow quickly. But they can also shrink. Let's look at one where they shrink. U sub 1 is 256. U sub n is equal to 3/4 times u sub n minus 1. And we use this rule when n is greater than or equal to 2. Now I'm going to grab my calculator for this one because I can't do this all in my head. So here's my calculator, normal mode. All right, the first term. Ooh, man, you're probably looking at this, and if you're anything like me, you're thinking, oh gosh, there's a fraction. I'll never be able to do this. Well, don't worry. Fractions are numbers. We'll use them just like every other number. And at the very least, you should be able to get the first term. What's the first term? Oh, u sub 1. It tells me right there. Ooh, I'm going to draw my dividing line because I get confused easily. The first term is 256. The second term. Well, how do I find the second term? N is 2, so I got to use this. It says to find the second term, I do 3/4 times the previous term. So to go from here to here, I'm going to multiply by 3/4. So let's see, I got to grab my calculator for this. 256 times 3/4. Well, how do I put in 3/4 on my calculator? This calculator will let me put in fractions, but you may not have one that does. So we can put this in like this, 3 divided by 4. That'll work. Oh, I get 192. So the second term is 192. What about the third term and the fourth term? Well, to find the third term, we're going to do the same thing. We're going to multiply by 3/4. So 192 times 3/4. I get 144. How do I find the fourth term? Take 144 and multiply it by 3/4. Now in this calculator, I can just go times 3 divided by 4, and it'll tell me the next term, 108. Now, depending on your calculator, if you do that where you just type what you're going to do to the number before, you'll get something like the answer times 3/4. If I want to find the fifth term on this calculator and lots of other calculators, if you hit the equals button again, it'll perform that same operation. But this time, 108 is the answer, so it'll tell me the next one is 81. And the next one is 60 and 75/100ths. And the next one, 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 and the next one. Just hitting the enter key. You don't have to type it in every single time. That's a handy trick from me to you. You're welcome. So let's see if you can do one of these. I'm going to put it over here. Here we go. U sub 1 is 200. U sub n is 1/2 times u sub n minus 1. See if you can write down the first 5 terms. I'll wait. All right, if you can't do anything else, you can at least get the first term. The first term, 200. The second term, well, how do I find the second term? I gotta go to my rule. It says to find the nth term, I do 1/2 times, what does this mean? The previous term. So to go from here to here, 1/2 of 200. So you can do this a couple of ways. You can think in your head, what's 1/2 of 200? You can put in on your calculator 200 times 1 divided by 2. Or if you know that 1/2 is 0.5 as a decimal, you can go 200 times 0.5. Oh, that's 100. Now to get the next number, I'm just going to type times 0.5. Because to go from the second number to the third number, I'm going to multiply by 1/2 again. 100 times 1/2 is 50. Well, how do I get the next number? Multiply by 1/2 again. 50 times 1/2 is 25. How do I get the fifth term? Multiply by 1/2 again. 25 times 0.5 is 12.5. Did you get this? Nice job. Whoo boy, that was a whole lot of information. Good luck with this. And next time I'll talk about how we can use a sequence to write the formula. All right, thanks. Bye.